All right, this is our second factoring. Um, it's a continuation, three-term polynomials, trinomials we call them. But there's going to be one twist to it. The ones we did first were where a equaled 1, but now we're going to do them where a does not equal 1. Okay, so it gets a little bit tougher, but we still have a process, except we've added two little steps really to it. And step number 1 is you want to multiply, there we go, multiply a by c. And we'll refer to that value as just AC, because a times c will just give you some number. Notice now, when you find your RS here, R times S, instead of them multiplying to add up, or multiplying to give you C, they multiply to give you this new number we calculated, A times C. But your R plus S still has to be equal to the B value. So the only thing we're changing is what they have to multiply to. Also of note, though, is your factors when you get done. Your factors are going to be AX plus R and AX plus S. So it's not just going to be X plus R. It'll be AX. What's AX? Well, AX is just whatever A is in the polynomial. Then you're going to do a little GCF, so that's new again, to both factors and cross those GCFs out. And then you'll be done. Okay? So I'll walk you through this step. This section, AX plus R, AX plus that much tougher. So step 1, I guess, and I didn't even have this really listed as a step because now it should just be natural to us. We are going to look for a GCF. We don't have one here. So no GCF. This was 3 is only divisible by 3. 10 is not divisible by 3. And we don't have an X in this last term, so we don't have anything we can take out. So we are going to try to factor it straight up by going to parentheses like so. And this is why these problems are tougher, because it's 3x squared here, so it could be 3x times x or x times 3x. And then the 7 could be the 1 times 7 or 7 times 1. So it's trying to get things in the proper spot is going to be tough. Now, as a little starter for this thing, since we know a is equal to 3 here, we could also write this ax at this point, 3x and 3x. Okay, don't worry about the fact that 3 times 3 there isn't going to give this 3x squared. This is just part of s. So let's finish writing down b here is negative 10. That's going to be important to us. And c is equal to 7. So find out what AC is. Let's go and get our R value. So AC is equal to 3 times 7, or 21. And now we're ready to find R and S. So R times S has to be 21. So 1 times 21, or 3 times 7. Those will give you 21. Let's see here. They have to add up to negative 10 in the middle. If I add these up, these add up to 22. If I add these up, they add up to 10. Now I want a negative 10. Well, if I made them both negatives, they would give me negative 10 when I add them. And do they still multiply to give me the positive 21? Yes, they do. So I know it's negative 3 and negative 7. So I go negative 3 and negative 7. Now here comes the GCF part. Look at this binomial. They're both divisible by 3. So you want to factor that 3 out, leaving you with an x minus 1. Divide each one by 3. The second one doesn't have a GCF, so you just rewrite it. 3x minus 7. And then just cross out that GCF. And there's the factorization. X minus 1, 3x minus 7. And you can check this. X times 3x, that gives me the 3x squared. Negative 1 times negative 7, the last term, is multiplied to give you the last term, 7. And then this outside, negative 7x, negative 3x, they add up to the negative 10 in the middle. Another example. Check for a GCF. Nope, don't see one. So we're going to multiply it like this, and I know it's going to be a 5x and a 5x to start with, because a is 5x squared, or a is 5, but it's got the x next to it. B is the negative 14. C is the 8. And that's what they have to add to. And A times C. So 5 times 8 is 40. So R times S, they have to multiply to give me a 40. But they've got to add up when I write them down to a negative 14. So let's worry about the multiplication first. It could be 1 times 40. It could be 2 times 20. It could be 4 times 10. It could be 5 times 8. 6, 7, then we get to 8 times 5, so we'd start repeating. They have to add up to negative 14. Well, these two add up to, working across here, I know why I keep doing that, but add equals, they either equal 41, if they're both negative, they could be negative 41. I know they have to have the same sign because they multiply to 40. Because they get to a negative 14, it also tells me they both have to be negative. So I'm going to go ahead and mark those, and we'll just do all their negative sums. So this would be negative 41. This would add up to negative 22. This would add up to negative 14. This would add up to negative 13. I think I wanted to stop right there, though. Those two, negative 4 times negative 10, multiply to 40. Negative 4 plus negative 10 adds up to the negative 14, our B value. So it's just going to be minus 4 minus 10. We check for a GCF. 5x minus 4 does not have one. But 5x minus 10, I could take a 5 out and just cross him away. X minus 2. And we could check it again. First terms, 5x times x, 5x squared. Negative 4 times negative 2 is the 8. Then this outside is negative 10. This is negative 4x's. They add up to negative 14. Let's check for a GCF. Divisible by 5, not divisible by 5. No GCF. So let's write down our base here. It's going to have to be a 5x and a 5x. A is 5, B is negative 52, that's key. This negative right away tells me that, well, it doesn't tell me anything quite yet until I look at this C value. And I'll explain why. This C value being positive and this being negative, this tells me that both the R and the S are going to have to be negative numbers. They multiply that way. If they're both negative, they multiply to a positive, and the two negatives would add up to a negative. So that kind of helps you out sign-wise. But R times, A rather, times C, we got to calculate that. That's 100. That's 5 times 20. So R times S has to give us 100. So 1 and 100, 2 and 50, not 3, but 4 and 25, 5 and 20, not 6, 7, 8, 9, but 10 times 10, that's halfway, and then we just start repeating again. Let's see here. I said they have to multiply to give me a positive 20, but they have to add to negative 52. So they're both going to have to be negative to get me to positive when they multiply. Let's just see here. I want them to add up to 52. There we go. They multiply, but they add to negative 52. Right there. So it's minus 2 and minus 50. See, it looks like there's a GCF in the second binomial. I can take everybody, divide them by 5, and cross out that 5. So it must be 5x minus 2 times x minus 10. And we're done. I'll leave it there. Last one, nope. Rest is assignment. That's it.